And now let's do an all-in-one question. So the question says find the derivative of f of x equals this thing using the first principle, and it's 6 marks. If you can do this question, then this basically means you can do all the first principle questions out here. This is literally the hardest question type you can get. And let's just do it. So first principle, you just write out the formula. This step is not necessary, but I prefer to write it, so you can tell me what to do. After the formula, you just substituting your f here. So this is your f of x plus h. You just substitute all the x here to x plus h. So the x cubed here becomes x plus h cubed. And the same thing is for x plus h squared as well. And then minus this, your f of x original expression. For the h in the denominator, I just put it out in the front because I want to save space. But beware that you can only put the 1 over h here, not outside the limit. And at this step, we don't want to see two fractions minus together in an expression. We want to make them into one term. So we can somehow factor an h out in the numerator and cancel with this h in the denominator. So to get these two terms into one term, we need to get a common denominator. And in this case, the common denominator will be this times this. So for the first term, we multiply the top and bottom by this thing. And for the second term, we multiply top and bottom by this thing. And now the denominator of the two terms are the same. We can simply merge the fractions together. And now we have this. Just be careful, there's a minus sign here. And now we have two square roots on the numerator, and we don't want to see square roots because we can't expand the square root. So to get rid of it, we basically need to use the difference between squares formula. What you do is you multiply the top and bottom by the conjugate of the numerator. So you just change this minus sign into a plus sign here. These two things are the same, so you multiply 1 here, you doesn't do anything. And after you multiply by the conjugate, you can use the difference between squares formula. It's a squared minus b squared. And then the square root and the square will cancel out. This will get rid of all the square roots on the numerator. And you can observe the denominator now is getting really horrible now. But from now, you can just leave the denominator as it is. You won't do anything to it until the last step. Okay, next slide. This is where the question gets really annoying. This is expression we got from our last slide. The square root are gone now. So you need to expand the cube and the squares now. Just using the formula. The cube term will expand like this. And the x plus h squared will be equal to x squared plus 2hx plus h squared. And remember there's a 2 in front. And now you just basically need to multiply this minus sign in to cancel out with the front part. So basically all the plus sign here becomes a minus sign. And also there's a 2 here, so these three terms will be doubled. And now you can cancel out. That is basically the most satisfying part of first principle questions. So this s cubed term cancels out. And 2s squared also cancels out with the 2s cubed here. And the plus 1 and minus 1 at last also cancels out. And you can actually notice that the first three terms that cancels out is actually the same thing as the terms in the original f of x expression. This will always happen for a first principle question. If you've done all the steps correctly, then all your terms of the original f of x will cancel out. And then you are left with a bunch of terms that all contain an h in it. So by this way, you can factor out an h from all these terms. So you take this h out, this h squared becomes an h, this h cubed becomes an h times h squared, and then the same thing is true for the next two terms. And then now you can just cancel the h on the numerator and the denominator. Because h is not equal to 0, you need to write this thing. And now there is no single h in the denominator. You can safely plug in h equal to 0. So all the terms I highlighted in yellow are basically gone now because they're 0. And then you are left with this. So now you're basically done almost all your work now, just left with some cleaning up. As you can see, although the first principle questions are somewhat looked very horrible at first glance, but actually they are not very hard to do, because basically half the time you are doing is you copy down the ridiculously long denominator here and also this limit sign. And you need to do this thing every time. Every step, copy them down. It's very annoying, but you need to do it. It's actually part of a marking scheme. If you left out a limit sign here, somewhere in your step, there will be surely a markdown for you. And this is our f prime of x from our last slide. I highlighted this thing in orange so you can see that this and this square roots, these two are basically the same. So you can put them in a squared. And these two things are also the same, and when two things the same are plus together, this gives you twice that thing. And also the numerator, both terms are negative, so you can take our negative sign in front and turn it into a plus. So I have this, just simplify it. Obviously this square root and this second power just cancels out. It's for a normal bracket, and you can take these two in front just so it looks better. And so this is basically your final answer. You have earned 6 marks from this. And let's just have a check with some power rule. So f of x given in the question is this thing, and because it's 1 over the square root, you can write it as 1/2 power. And if you want to take the derivative, you just use the power rule. It's very easy. You take this minus or half out in front, and then you minus 1 to the power. But beware, because the thing inside the bracket here is a bit complex, it's not a linear term or just one thing, you also need to multiply the derivative of the thing inside. So you need to take the derivative of this thing. But take the derivative of this thing is very easy. You just use the power rule again. X cubed, you take derivative, is just 3x squared. And 2x to the power 2, you take derivative. You move the 2 down. 2 times 2 is 4, and 2 minus 1 is just 1. And the derivative of 1 is just basically 0. You don't need to care about it. And of course, this thing, minus 1/2, minus 1 again is minus 3 over 2. And then you move this negative power up to the denominator. Here becomes a positive 3/2 power in the denominator. So if you remember, whenever you have a thing to the 3/2 power, you can write it as the thing itself times the square root of it. And this matches our answer from our first principles. So for why this last step here is true is because whenever you have x to the power of 3/2, then you can write it as x to the power of 1 plus 1/2. As you know, 1 plus 1/2 is 3/2. And then you just use your index law to separate this. So it's the same as x to the power of 1. And then times is times here, x to the power of 1/2. And as you know, x to the power of 1 is just x. You don't need to write the power of 1. And x to the power of 1/2 is just square root of x. So this useful identity here, anything to the power of 3/2 is just the thing itself times the square root of it. But anyway, you have done this question. Let's just have a quick review because this question is very long. So the question is here, 6 marks. Where then comes from? So basically, the first mark here is 1. You basically just substituting f of x plus h here. You need to correctly identify what does f of x plus h looks like. This first mark. And the second one is get a common denominator of these two things. This is the second mark. And then the third mark comes from multiply the conjugate here. You change this minus sign into a plus sign. This is the third mark. And then the fourth one comes from expanding it. So this cubic expansion and the quadratic expansion gives you the fourth mark. And then just a lot of algebra cancel out. There's a lot of things canceled out. You factor out an h. So all this algebra thing gives you the fifth mark. and then you let h equal to 0. You basically let all these things go to 0, and then after you simplify, you get this final expression. This gives you the 6 mark. And another thing is during our questions, you need to always write this limit sign here. If you omit the limit sign anywhere, you mark you down. This sign here forms a part of your whole structure. It's like the denominator here. If you omit them anywhere, you lose a mark. And that's all for today. Thank you, guys.